Hello students, today we start with the first lesson of class 10th. Let's start with this. What is that? Chemical reactions and equations. So first we'll see what are chemical reactions and how to write the equations. Different types of chemical reactions are explained in this lesson, and the equations how to write and also balance the equations. Let's see. So consider the following situations of daily life and think what happens when. So just think when milk is left at room temperature during summers. So milk, we didn't keep it in fridge. So what happens after some time? We'll see. It will get sour. After that it will be converted into curd, or it will be rotten, right? Then an iron tawa or pan or nail is left exposed to humid atmosphere. So what happens? It gets rust. Then grapes, when get fermented, what happens? It will be converted into wine. When food is cooked, what happens? It will get cooked and it changes its texture. Then when food gets digested in our body, its structure is also changed. Complicated molecules are converted into simple glucose molecules. When we respire, what happens? Oxygen is taken inside and it will be carried out to the lungs and all the body parts. In return, carbon dioxide is coming outside, exhaled out. So like this, in all these activities we see in our daily life, there will be reactions taking place. These are nothing but chemical reactions or chemical changes. In all the situations we will find one thing: a new substance or the substance which is there already have changed somewhat. So in the above situations, the nature and identity of the initial substance have somewhat changed. Initial means first substance. It is changed somewhat. So we have learned about physical and chemical changes in our previous classes. Physical changes are changes which occur because of the physical properties which we see. Yes, no? And chemical changes are the changes in the chemicals in it, present in it, and new product is formed in a chemical change, whereas in physical change no new product is formed. So like this we can say whenever a chemical change occurs, we can say a chemical reaction has taken place. So whenever chemical change occurs, we can say that a chemical reaction is taken place. You may have perhaps be wondering to what is actually meant by chemical reaction. So we will discuss this by performing an activity. So let's see what is that activity. See here, clean a magnesium ribbon about 3 to 4 centimeters long by rubbing it with sandpaper. So by rubbing it with sandpaper, we should clean a magnesium ribbon. Hold it with a pair of tongs. So they hold that magnesium ribbon with a pair of tongs and burn it with the help of a spirit lamp or burner, and collect the ash in a watch glass. Burn the magnesium ribbon, keeping it as far as possible from our eyes because it is dangerous. So when we burn a magnesium ribbon, we will see there will be a white dazzling light will be released, and the ash which is collected here is nothing but magnesium oxide. So what is the chemical reaction took here? Why we have to rub the magnesium ribbon with the sandpaper? Let's see. So when magnesium is burnt, it reacts with the oxygen present in the atmosphere to form magnesium oxide. And why we have to rub the magnesium ribbon with the sandpaper? Because magnesium ribbon, when it is kept open, it will be reacted with the atmospheric oxygen and a thin layer of magnesium oxide will be formed outside, so that the reaction will not take place correctly. So to remove that, we have to rub it with the sandpaper before doing the experiment. first have observed that magnesium ribbon burns with dazzling white flame and changes into white powder. This powder is nothing but magnesium oxide. It is formed due to the reaction between magnesium and oxygen present in the air. So here reaction is took place and magnesium oxide product is formed. So one more activity, let's see. Take a few zinc granules. So we have to take few zinc granules and add dilute hydrochloric acid or sulfuric acid to it. Then handle the acid with care while pouring it, and touch the conical flask or test tube. When we touch it, we can see there is a change in temperature. It will become hot, warm. Yes, no. So from this we can say the chemical reaction took place and the hydrogen gas will be released, that will be coming outside. So from the above activity we can say that the following observations helps us to determine whether a chemical reaction has taken place. So when we do one reaction, how can we know that a chemical reaction has taken place? We can know by seeing its change in state. When a chemical reaction takes place, there may be a change in a state, its physical state, or change in its color, or evolution of gas, or change in its temperature. So when these occurs, then we can say that a chemical reaction takes place. Now they may ask the questions, what are the observations, or how can we know a chemical reaction takes place, or what are the observations we can find when a chemical reaction takes place? So like this it is asked, we can say that when a chemical reaction takes place, the following changes we can see like change in state, change in color, evolution of gas, or change in temperature. So as we observe the changes around us, we can see that there is a large variety of chemical reactions taking place around us, and we will see it in the various types of chemical reactions and symbolic representation of it also. So first see what are chemical equations. So in the activity already we saw when a magnesium ribbon is burnt in the oxygen, it gets converted into magnesium oxide. So the description of chemical reaction in a sentence we can write, but it is quite long and we want a shorter forms. The simplest way to do this is to write it in a word equation. So the word equation, how we can write? Magnesium plus oxygen, which are the reactants which react together to form magnesium oxide product. The substances that undergo chemical change in a reaction are called reactants, and the new substance which is formed is nothing but product, magnesium oxide here. So again the word equation when we write, so it is also a lengthy, we know that. Yes, no. So to again simplify it, we are writing it in a chemical equation form. Here we can observe the reactants are added together with a plus mark, and it is an arrow mark to tell it is giving rise to products here. Yes, no. Then how to write a chemical equation? So in order to represent it in a very short form, we will use a chemical equation by writing its symbols. So what is the symbol of magnesium? It is nothing but Mg, and oxygen O2. So Mg and O2 are the reactants added with plus. It both reacted together to get a product called magnesium oxide. Its symbol is MgO. So and we have to write the chemical equation like this. Before balancing it, we can call it as unbalanced chemical reaction, or we can call it as a skeletal chemical equation. So it is a skeletal chemical equation because it is not balanced, because here magnesium is 1, oxygen is 2, but when we see here only 1 oxygen is there, 1 magnesium is there. So the reactant side and product side, when we count the atoms, they are not equal. So it is a unbalanced chemical equation, or we can say it as skeletal chemical equation. Then so when we balance this equation, then it is called balanced chemical equation. So why we have to balance a chemical equation? So because we already studied in class 9 the law of conservation of mass. So that is mass can be can neither be created nor destroyed. We cannot create a mass, or we cannot destroy it also in a chemical reaction. So the total mass of the elements present in the products of a chemical reaction should be equal to the total mass of the elements present in the reactant side. So the total mass of reactants is equal to total mass of products. So like that, number of atoms present in reactants should be equal to the number of atoms present in the product. So how can we do that? We can do that by balancing a chemical equation. So for balancing the chemical equation, let me explain it with the step-by-step process. Step 1 is first draw the boxes around the formula, or do not change anything inside the boxes before balancing the equation. So first we should write the boxes for the chemical reaction. So Fe plus, write the boxes, H2O gives, write the boxes, Fe3O4 plus H2. This is the first step they told. Then when come to next step, calculate the number of atoms of different atoms present in it. So we can write reactant side or product side, reactant side or LHS side and product side. Just divide it and write the atoms. Iron, hydrogen, oxygen are present. So iron, how much is there in the reactant side? 1. Hydrogen, how much are there? 2. Oxygen, how much is there? 1. Then we will see the product side. Iron, how many are there? 3. Hydrogen, how many are there? 2. Oxygen, how many are there? 4. Then here see, iron is not balanced, oxygen is not balanced. Then we start balancing. That is the third step. So initially we have to balance with the element which have maximum number of atoms. So we can see here oxygen, which has maximum number of atoms, it is having 4, but here it is having only 1. So to make it 4, multiply it with 4 to get 4. So here we multiply it with 4. So now we got oxygen is 4, but along with that hydrogen is also changed. It became 4 2s 8. It became 8. Then if we see, so what happened? It is 8 and it is 2. Then to make it 8, what we have to do? It is multiplied with 4 to make it 8. So 2 4s are 8. So here we should keep 4. So 4 2s are 8. So these two are balanced and this is not balanced. So here Fe is 3 and here it is 1. So to make it 3, we multiply it with 3. So is equal to 3. So we keep here 3. So that all are balanced now. So next step is we will write the equation now. So they gave step 3, step 4 and step 5 also balancing 1 1. So but I balanced everything in the step 2 only. So the next step we should write removing the boxes. 3 Fe plus 4 H2O gives Fe3O4 plus 4 H2. So this is the balanced chemical equation in the final. So like this we can balance the equations. So I did already one video of how to balance the equations. You can check it. Now we'll go to our lesson part. So next step after we balance, we have to write the symbols or physical states of the substance. So as iron is a solid, we will write FeS, and water as we get it in a steam. So when we make it as a steam by boiling, then only it will react. So gas, and we'll get here Fe3O4, which is nothing but solid, and hydrogen released is a gas. So G. Like this we represent the physical states also. The symbol G is used to water, indicates that reaction water is used in the form of steam. So using physical states are not included in actually chemical reaction or equation, but we have to specify them when they ask or when it is necessary. Then sometimes the reaction conditions such as temperature, pressure, catalyst for the reaction are indicated above or below the arrow. So for example, CO2 plus 2H2 gives CH3OH. Here when we give 340 atmosphere pressure only, it will happen. So it is represented here. And again 6 CO2 plus 12 H2O gives, in the presence of sunlight and chlorophyll, it gives glucose, oxygen and hydrogen. It is a photosynthesis process. So in the presence of sunlight and chlorophyll only this reaction happens. That's why the reacting conditions are specified above or below the arrow. So next. So like this. Then next part is types of chemical reactions. So we have already learned in class 9th, during a chemical reactions what happens? Atoms of one element do not change into another element, nor do atoms disappear from the mixture or appear from elsewhere. Then how actually chemical reaction takes place? So chemical reaction takes place by breaking or making of the bond between the atoms to produce new substance. So to produce the new substance, they may make the bond or break the bond. So we will study about these atoms in next chapters. So let's see. There are different types of chemical reactions explained here. The first one is combination reaction, after that decomposition, after that displacement and double displacement. So let's see first combination reaction. So for this again we'll see activity. Take a small amount of calcium oxide or quicklime in a beaker. So we have to take a calcium oxide or quicklime in a beaker. Slowly add water to this. When we add water to this and we touch with the hand, we'll see a change in temperature in this. So what is formed here? We took calcium oxide, which is nothing but quicklime, and we reacted it with water. So this calcium oxide reacts vigorously with water. What do you mean by vigorously? Very fastly, violently. Yes, no? It reacts vigorously with water to produce liquid lime. That is nothing but calcium hydroxide. So along with this, it will release a large amount of heat. So when calcium oxide reacts with water, calcium hydroxide is formed and lot amount of heat is produced. So what is the reaction occurring here? The two reactants are combined, means calcium oxide and water both are combined to form calcium hydroxide, and heat is produced in this process. So the name itself, it is telling combination. So calcium oxide and water combined to form calcium hydroxide. So such a reaction in which a single product is formed from two or more reactants is known as combination reaction. So what is combination reaction? When two or more elements or reactants combine to form a single product, it is called combination reaction. So let's discuss. Some more examples like burning of coal. So carbon plus oxygen gives carbon dioxide, or hydrogen plus oxygen combined to form water. In simple language we can say two or more substances combined to form a single product. It is called combination reaction, and in this process so much of heat is evolved. Evolved means released. So the reaction mixture becomes hot, warm. So the reactions in which heat is released or produced along with the formation of products are called exothermic chemical reactions. So generally combination reactions are, some reactions are exothermic reactions, not all. So exothermic reactions means what? Exo means exit. Thermic means heat. Heat is exit, means heat is released out. So in simple language, exit of heat. Then some examples of exothermic reactions like burning of natural gas. When the natural gas is burned, like methane, CH4 plus 2O2 gives CO2 plus 2H2O. Along with this, so much of heat is produced. And even the respiration is also an exothermic process. Just exhale and see, we'll see warm air coming outside. So it is an exothermic process. We all need energy to stay alive. So how will get energy? the food from we eat. So during digestion, what happens? The food is broken down into simple substances. So whatever we eat rice, potatoes, bread, so all these contain carbohydrates. These all carbohydrates are broken down into glucose. This glucose will combine with the oxygen in the cells of our body while we respire, and it will produce energy. So the special name for this reaction is nothing but respiration. So this is there, this lesson respiration is there in the life process lesson. In the next lesson of our biology, let's see there. So here C6H12O6 glucose, which is formed from the food, reacts with the oxygen which we respire to release carbon dioxide. We exhale out carbon dioxide, right? Along with that, some water and energy is released. So the energy is used by us. Then the decomposition of vegetable matter into compost is also an exothermic reaction. It also releases so much of heat. So identify the type of reaction takes place in activity 1.1, where heat is given out along with the formation of a single product. What is our activity 1.1? Magnesium ribbon reacts with oxygen. Here also heat is released. So it is also a exothermic reaction. So magnesium oxide, which is a single product, is formed. So it is also a combination reaction. So heat is released, exothermic reaction and combination reaction also. So next type of reaction is nothing but decomposition reactions. For this, first let me explain activity to understand it. Listen carefully. Take about 2 grams of ferrous sulfate crystals in a dry boiling tube. Remember, dry boiling tube. Take 2 grams of iron sulfate crystals. So note the color of the crystals and heat the boiling tube over a burner or splinter as shown in the figure. So we should burn it and we can see the color of the crystals will be changing. So you notice that the green color of ferrous sulfate crystals has changed. You can also smell some odor of burning sulfur also. So what is the reaction here going on? So ferrous sulfate crystals, FeSO4, when heated, it will form ferric oxide, Fe2O3, SO2, SO3 gas is released. So only one reactant is broken down into so many products, we can see here. So in this reaction, only a single reactant broken down into simpler products. So this is a decomposition reaction. Why we used ferric sulfate crystals? In an only dry boiling tube, as I already told before, because ferric sulfate crystals have water hidden in it. So 7 water molecules hidden in it, FeSO4, 7 H2O. So when we heat it, it will lose that water and the color of the crystals changes. And after that, it decomposes to ferric oxide, sulfur dioxide and sulfur trioxide. So ferric oxide is a solid and SO2 and SO3 are gases. So again, one more example also we can take, like calcium carbonate. When we heat it, so it will form calcium oxide and carbon dioxide. On heating, it is also an important decomposition reaction used in various industries. So again, calcium oxide is nothing but quicklime. So we saw it in the before reactions also. So it may be used in the manufacture of cement. So when a decomposition is carried out like this by using of heat. So here all we are using it heat. These reactions are called thermal decomposition. By using of heat, it is decomposing. So it is called thermal decomposition. So another example of thermal decomposition is also given here. Heating of lead nitrate and emission of nitrogen gas. Brown color fumes we can see when take 2 grams of nitrate powder in a boiling tube and hold it with a pair of tongs and observe the flame. You can see emission of brown fumes that are nothing but nitrogen dioxide. The reaction took place here is what? So lead nitrate, when is heated, it forms lead oxide, nitrogen dioxide and oxygen gas is released. So this is a decomposition reactions. Here we are seeing that the heat is taken. What is happening here? Heat is taken. In the combination reactions, heat is released. But in the decomposition reactions, we are seeing heat is taking out. So, it is taking inside the heat. So, these are all called endothermic reactions. Endo means taking inside, thermic means heat. So again, not only by heat, we can give other energies also for the decomposition reaction to take place. For example, when current is given. Let's see, first take a plastic mug. Drill 2 holes at its base and fit rubber stoppers in the holes. Insert carbon electrodes in these rubber stoppers and connect these electrodes to a 6-volt battery. So, it is connected to a battery. For power connection, fill the mug with water such that the electrodes are immersed and a few drops of dilute sulfuric acid. When acid is added, current will be passed easily because pure water do not conduct electricity. So take 2 test tubes filled with water and invert them over 2 carbon electrodes. When we switch on the current and leave the apertures undisturbed for some time, you will observe some formation of bubbles at both the electrodes. These bubbles will displace water in the test tube, so that water will be displaced in the test tubes. As is the volume of the gas in both is same? No. We can see here in this more, in this less. Yes, no. So more water is displaced here. Here less water is displaced, means because H2O, 2 parts of hydrogen with 1 part of oxygen. So like this we can carry. Here what is the equation? H2O is displayed, is when we pass the current in it, it will be decomposed into H2 and O2. So this is the electrolytic decomposition reaction. Then when we take sunlight also, it is also a energy which we can use for decomposition reaction. So you will see that take 2 grams of silver chloride. So in a china dish, what is its color? It will be white color when we take. After we kept in sunlight for some time, we will see that it will turn into grey, because decomposition of silver chloride into silver and chlorine by means of sunlight. So because of sunlight, decomposition reaction takes place. So let's see the equation. AgCl or AgBr gives Ag plus Cl2 or AgBr2. Same silver bromide also same reacts in the same way. That's why only one equation. We can write A2AgCl is equal to 2Ag plus Cl2. So these reactions are used in black and white photography. So what form of energy is causing these decomposition reactions? Sunlight. So we have seen up to now the displacement reactions require energy. Yes, no. In all these decomposition reactions, we needed energy in the form of heat, light or electricity for breaking down the reactants. So the reactions in which energy is absorbed or taken inside are called endothermic reactions. So this is the about decomposition reactions. Next go with the displacement reaction. So what is displacement reaction? So take 3 iron nails. So what we have to take? 3 iron nails and clean them with rubbing with sandpaper. So after rubbing it, take 2 test tubes marked A and B. So we have to take 2 test tubes like A and B. I marked as A and B. So in each test tube, take 10 ml of copper sulfate solution. Fill it with 10 ml of copper sulfate solution and 2 iron nails with a thread. We should carefully drop in the copper sulfate solution in the test tube B. And after 20 minutes, we can see iron nail aside. Keep that iron nails for comparison. After 20 minutes, we can see iron nails from the copper sulfate solution. We can see comparatively the intensity of the blue color of copper sulfate solution will decrease, and the iron nail also will change its color. See here iron nail. So which is not dipped in copper sulfate solution, and iron nail which is dipped in the copper sulfate solution. We can see copper sulfate solution test tube B, nothing is dipped in it. In this, iron nail is dipped. So we can see the color of the blue solution will be become less intensity, and also the iron nail taking out from the copper sulfate solution is turned into brown in color. So why the blue color solution became faded and it became red brown? What is the reaction here happening is nothing but when iron is reacted with copper sulfate solution, it forms iron sulfate plus copper. So here it is changing its places. We can see here in the copper sulfate, copper is displaced by iron. So iron has displaced or removed another element, copper, from copper sulfate solution. So this is known as displacement reaction. This happens only when a reactive metal is reacting here. So only reactive metals can displace the less reactive elements. So other examples we can say zinc plus copper sulfate gives zinc sulfate plus copper, or lead plus copper chloride gives lead chloride plus copper. So as the name indicates, displacement, the place is changed. So zinc and lead are more reactive than copper, that's why they displaced its copper from its compounds. That is nothing but displacement reactions. And the next is double displacement reactions. As the name indicates, there will be change in the two places. So how it takes place, let's see. Take about 3 ml of sodium sulfate solution in one test tube. In one test tube sodium sulfate solution, and in another test tube barium chloride solution. When we mix both together, we will get a precipitate. The insoluble substance formed is nothing but a precipitate. Any reaction that produces a precipitate are called precipitation reaction. What is the reaction here going on is, let's see. So sodium sulfate reacts with this barium chloride. There will be a mutual exchange of ions. In the sodium place, barium will be coming. In the barium place, sodium will be coming. So there will be a mutual exchange of ions taking place to form a precipitate. So sodium sulfate became barium sulfate. Barium chloride became sodium chloride. So there will be a double displacement reaction. In the displacement reaction, only more reactive displaced, less reactive. Here both there will be exchange their places. So it is called double displacement reaction. So what causes this? Because the white precipitate BaSO4 is formed by the reaction of sulfate and Ba2 plus ions. The other product is nothing but sodium chloride, which remains in the solution. Such reactions in which there is an exchange of ions are called double displacement reactions. Next, what are oxidation and reduction reactions? Let's see. So for this we'll do a small activity. So we have to take copper powder in a china dish, and we have tripod stand here, and with burner, when we burn the copper powder, black copper oxide powder will be formed. So what is the reaction here? Copper when reacted with oxygen. So when we give heat, it forms copper oxide. So here oxygen is added to the copper. So it is oxidation reaction, and oxygen added to the copper to form copper oxide. So again, when the hydrogen gas is passed over this heated material, so into this copper oxide which is formed, when we send or pass hydrogen gas, again it will be reduced. What do you mean by reduced? Removal of oxygen. Addition of oxygen, oxidation reaction. Removal of oxygen, reduction reaction. So again, when we send the hydrogen or pass hydrogen into it, and when we heat, again the oxygen will be removed or reduced to copper. So Cu plus H2O. So if a substance gains oxygen during a reaction, it is oxidized. If a substance loses oxygen, it is reduced. So copper oxide is losing oxygen and being reduced. Hydrogen is gaining oxygen and is being oxidized. Both are done in same reaction. When we see here, copper oxide is reduced to copper, and hydrogen is taking oxygen, added oxygen, so it is oxidation to form water. So both oxidation and reduction reaction happening in only one reaction, then it is called redox reaction or oxidation reduction reaction. So some more examples they gave, like zinc oxide plus carbon gives zinc plus carbon monoxide. What is reduced here? Zinc oxide is reduced to zinc, and carbon is oxidized to carbon monoxide. And MnO2, manganese oxide plus hydrochloric acid, if we do manganese chloride plus water plus chlorine. So like this, manganese oxide is reduced to manganese chloride and hydrochloric acid is oxidized to water. So like this, we can see both reduction and oxidation reaction in this. Next, last topic of this lesson is how the effects of oxidation reactions occurs in our everyday life. When we see, there are two effects here, they are given. Normally we see in our daily life, they are corrosion and rancidity. So what is corrosion? So when the iron articles, so when we buy it, it will be very shiny, but after some time we keep it outside to the atmosphere, then it will be coated with reddish brown powder, that is nothing but rusting of iron. So other metals also will also get rust. So this type of metals which gets corroded by means of moisture, acids, etc., it is called corrosion. When we see silver articles, when we take, it will be shining before, after that it will be coated with black, and even the copper articles also, it will be corroded and turns to green color. So what happens because of corrosion? Like car bodies, bridges, iron railings, ships, all will get damaged because of the corrosion. So to remove that or to stop that, because it is a serious problem, waste of money to replace damaged iron, how can we stop the corrosion? We can paint it. Yes, no, we can paint the iron articles to avoid the corrosion. Then what is rancidity? So take chips, you leave it for so many days, and when we eat, what happens? We can see the difference in the taste, yes, no, and also the smell. So when fats and oils are oxidized, so whatever are the fats and oils present in that food material, when they get oxidized, they become rancid. Rancid means their smell and taste changes. So usually substances which prevent oxidation, like antioxidants, are added to the food, that is called preservatives. So which prevent the oxidation, that will be added to the foods containing fats and oils. So or we can keep the food in airtight containers to slow down this oxidation. So like the chip manufacturers, we see Lay's, Bingo, all these, they will be flushed with air something. So only half will be there in the food and half will be flushed with air. What is that air? That is nothing but nitrogen. So the nitrogen will prevent the chips from getting oxidized. So it remains fresh for so many days. That's why they will fresh nitrogen in that. So to prevent rancidity. So that is about our lesson. types of chemical reactions, equations. Thank you.